Welcome student with a new topic, Z transform. If you want to do the Z transform, you must remember here the basic things. First is the geometric progression, that is the GP. The numbers A, AR square, AR cube are said to be GP. GP means what? Geometric progression. There we know that is the common ratio. Here A, then AR, then AR square, AR cube. It means that here R is a common ratio. And for this geometric progression, you remember nth term. How to find nth term? That is equal to A R raised to n minus 1, where A is the first term and R is common ratio. And sum of nth terms, that is Sn equal to A into 1 minus R raised to n upon 1 minus R. Yes, this is the second one. So without fail you remember this second, because most of the problem to find the Z transform I will use this one. So what is that? Summation k varies from 1 to infinity R raised to k equal to R upon 1 minus R, where mod of R is less than 1. And if that summation k varies from 0 to infinity R raised to k, note that here k is 1 to infinity, here k varies from 0 to infinity R raised to k, that is equal to 1 upon 1 minus R. If 1 to infinity, then R upon 1 minus R, and if 0 to infinity, it is 1 upon 1 minus R. In both cases, mod of R is less than 1. So you must remember this, and you can see that by these formulas or by this summation formulas, it is easy to find Z transform of any function, means any sequence. Also, you remember this standard series that you already know, that is the log of 1 plus x, that is equal to x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus dot and so on. So same thing I can write with minus x. So log of 1 minus x means x replaced by minus x. I am getting here minus x square by 2 minus x cube by 3 minus x raised to 4 by 4 plus and so on. Actually here should be minus. So minus and so on. One more series there, that is e raised to x, that is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial plus and so on. Also you remember, in short, that is the what is the sequence? An arrangement of real or complex valued terms with some definite rule is called a sequence. And normally sequence denoted by this f of k. Here you can see here f of k. A sequence f of k is represented by two ways. One is list of elements and second is starting property or general term, you can see. So here is one example, supposed to be f of k equal to minus 2, 0, 2, 4, 6 and 8. So here arrow, it means that it is 0. This is the first, this is second. Here minus 1, minus 2, minus 3. In this example, f of 0 equal to 4, f of 1 equal to 6, f of 2 equal to 8. How? Let's see here again. So here, it is f of 0. It is f of 1. Here f of 2. Here f of minus 1. Here f of minus 2. Here f of minus 3. Like that. Similarly, in this case, you can consider the all things. Now the Z transform. So define Z transform. If f of k is a sequence defined for all integer k, positive and negative, then Z transform of f of k is denoted by Z of f of k and is defined as Z of f of k equal to f of z, and that is equal to summation k varies from minus infinity to infinity f of k into z raised to minus k. Note that there whatever f of k you just consider here and into z raised to minus k, where k varies from minus infinity to infinity. So this is the definition of Z transform. You also note that a sequence f of k is said to be causal sequence if f of k equal to 0 for all k less than 0. It means that here k defined minus infinity, here 0, here infinity. So less than 0 means here minus 1 to minus infinity. If f of k equal to 0, it means that actual values from 0 to infinity. Then the Z transform of this sequence means causal sequence is given by z of f of k equal to, only in this definition k varies from 0 to infinity. Also, if f of k is defined for m is less than or equal to k is less than or equal to n, it means that in between m to n, then the z transform of f of k is given by, only this k varies from these two values m to n. So you can see here z transform of f of k, that is nothing but f of z equal to k varies from m to n, f of k into z raised to minus k. So you remember here whatever the values of k defined, then summation f of k into z raised to minus k is nothing but the z transform of f of k. Student, I suggest you, if you want to do this z transform, means to solve the examples on the z transform, you must remember this table as it is. How to get this? Definitely when we start the examples, that time we will see here how to find z transform of these standard sequence. So if f of k equal to cos of alpha k, where k is greater than or equal to 0, then the z transform of this cos of alpha k is nothing but z into z minus cos alpha upon z square minus 2z cos alpha plus 1, where mod of z is greater than 1. Sin alpha k means when f of k equal to sin alpha k, with the same condition k is greater than or equal to 0, then z transform sin alpha k is z sin alpha upon z square minus 2z cos alpha plus 1, where mod of z is greater than 1. The z transform hyperbolic cos alpha k is nothing but z into z minus hyperbolic cos alpha upon z square minus 2z hyperbolic cos alpha plus 1, where mod of z is greater than maximum of mod of e raised to alpha and mod of e raised to minus alpha. Similarly, z transform hyperbolic sin alpha k, where k is greater than or equal to 0, is z into hyperbolic sin alpha upon z square minus 2z hyperbolic cos alpha plus 1. Again the same condition here, mod of z is greater than maximum of mod of e raised to alpha and mod of e raised to minus alpha. So you can observe, easy to remember. If you see there cos alpha k and sin alpha k, what is the denominator? Z square minus 2z cos alpha plus 1. Here also z square minus 2z cos alpha plus 1. Same denominator. Only change in the numerator. If cos alpha k, then here z into z minus cos alpha. And here if sin alpha k, numerator is z into sin alpha. And if we want to find hyperbolic functions, so same formula, only here this changes, circular function changes to hyperbolic function. You can observe. Also you continue this table for a raised to k. Note that here a raised to k, where k is greater than or equal to 0. Then z transform of a raised to k is z upon z minus a, where mod of z is greater than mod of a. And a raised to k, when k is less than 0, means condition, you can see here condition, k is less than 0, then the z transform of a raised to k is z upon a minus z, where mod of z is less than mod of a. Z transform of k is nothing but z upon z minus 1 whole square, where k is greater than or equal to 0. And a raised to k upon k factorial, then the z transform of this a raised to k upon k factorial, where k is greater than or equal to 0, is nothing but e raised to a by z. So note that here by using the first one I can find the remaining, because easy to remember, denominator is near about same. And here if we have a raised to k, where k is greater than or equal to 0 and k is less than 0, this you remember. So student, you must remember this table as it is. Then easy to evaluate the z transform of any sequence. So let's see the examples on this. But before to that, one more thing you have to remember here, properties of z transform. So what are the properties of z transform? So here the properties of z transform. Z transform of a raised to k into f of k. Note that here if we have z transform of f of k, notation is f of z, capital F of z. Then Z transform of a raised to k into f of k is nothing but f of z by a. It means that if you have a Z transform of this is f of z, if we multiply with a raised to k, then every z replaced by z by a. The same thing I can remember here. This is Z transform of a raised to k into f of k is nothing but it is a Z transform of f of k. What is f of z? It is Z transform of f of k. And here you replace every z by z by a. So like this also you can remember. Also you remember that Z transform of e raised to minus ak into f of k is nothing but f of e raised to a into z. It means that if we attach this one or multiply to f of k, then every z replaced by e raised to a into z. Z transform of f of k plus minus n, that is equal to z raised to plus minus n into f of z. These two are very important because here multiplication with k and division by k. So here Z transform of k into f of k is nothing but minus z into d by dz into f of z, and Z transform of k raised to n into f of k is nothing but minus z into d by dz raised to n into f of z. Note that here if square, so I will write here this is equal to, means square is, it is a minus z d by dz into minus z d by dz. Like that you have to evaluate. And Z transform of f of k by k is nothing but integration z to infinity z inverse, means z raised to minus 1 into f of z dz. Everywhere you remember this f of z is nothing but Z transform of this f of k. So consider one example on the Z transform. Here it is a standard Z transform, that is a Z transform of a raised to k equal to z upon z minus a, where mod of z is greater than a and k is greater than or equal to 0. So let's see the solution for this. By definition of Z transform of any sequence, that is equal to summation k varies from minus infinity to infinity f of k into z raised to minus k, and therefore here f of k equal to a raised to k, and where k is greater than or equal to 0, and therefore Z transform of a raised to k, that is equal to summation k varies from 0 to infinity, because here k is greater than or equal to 0 only. It means that here if we consider minus infinity, here 0 and infinity, so define for 0 to infinity. F of k means here a raised to k and z raised to minus k. So since we have this one, that is summation r raised to k, but note that here there are two parts where k varies from 1 to infinity and k varies from 0 to infinity. So which is applicable here? So definitely 0 to infinity, and that is why r raised to k equal to 1 upon 1 minus r. So here what is a r? So you just write this in the form of a raised to or r raised to k. So that is equal to summation k varies from 0 to infinity. Same thing I can write a by z, because this z raised to minus k I can consider in denominator. So I am getting a by z and whole raised to k. And that is why if we compare, so what is value of r? A by z. And that is why I am getting here 1 upon 1 minus a by z, where r means mod of a by z is less than 1. So therefore I am getting here Z transform of a raised to k equal to, so multiply this numerator and denominator by z. So I am getting z upon z minus a, where mod of a is less than mod of z. So here mod of z is greater than mod of a, means same thing here. I am getting Z transform of a raised to k equal to z upon z minus a, where mod of z is greater than mod of a. If a is a positive, so need not to consider mod a. So you can observe here this, if we have this thing, then easily you can find the Z transform of any. So whatever there, you use definition first thing, and second thing is that you try to obtain R raised to K. And once we get R raised to K, you decide K varies from what, and then you use this or this formula. So very easily you can find Z transform of any sequence. Consider next example. Prove that Z transform of A raised to K equal to Z upon A minus Z, where mod of Z is less than A and K is less than 0. So here also the mod of A. So see there, again the same method. Solution. We know by definition of Z transform of A raised to K equal to summation K varies from Z transform of F of K equal to summation K varies from minus infinity to infinity F of K into Z raised to minus K. And therefore, here F of K equal to A raised to K, and here K is less than 0. Less than 0 means what? Here minus infinity to infinity, in between that 0, less than 0. It means that here minus 1 and minus infinity. And that is why I am getting Z transform of A raised to K, where K is less than 0 is nothing but summation K varies from minus 1 to minus infinity. F of K means A raised to K and Z raised to minus K. Again, I want to use the same formula for the summation 1 to infinity or 0 to infinity. So how? But here K equal to minus 1 to minus infinity. So make it positive. So how? So put K equal to minus M. So what is a minus K? It is equal to plus M. So definitely this Z transform of A raised to K, it becomes now summation when K equal to minus 1. If we consider like this, need not to consider, directly you can write, but for our understanding, here K to M because our substitution, and here minus 1 to minus infinity. So when K equal to minus 1, so I am getting M equal to 1, and K equal to minus infinity, M is infinity, and that is why I am getting this summation is M equal to 1 to infinity. A raised to K is what? Minus M, and Z raised to minus K means it is M. Same thing you write in the form of R raised to K, or here R raised to M. So how? So let's see here. Summation M varies from 1 to infinity Z by A. Note that here this is minus, that is why it is in denominator now, because power here minus M, so that in denominator raised to M. Since again the same formula, that is summation R raised to K, K varies from 1 to infinity and K varies from 0 to infinity. So here it is a 1 to infinity, so R upon, so 1 to infinity it is R upon 1 minus R, and that is why I am getting Z transform of A raised to K equal to R. R is what? Here Z by A upon 1 minus R means 1 minus Z by A, where R means mod of Z by A is less than 1. So simplify this now. So I am getting Z transform of A raised to K equal to, now here multiply numerator and denominator by A. So I am getting Z upon A minus Z, where mod of Z is less than mod of A. So you can see what we want to prove. So we have to prove Z upon A minus Z, where mod of Z is less than A. If A is a positive, then directly you can consider, otherwise mod of A. So which is your required. So hence prove. Now consider new example, that is the prove that Z transform of E raised to AK equal to Z upon Z minus E raised to A, where mod of Z is greater than E raised to A. K is greater than or equal to 0. So very simple way you can prove this one, or another way by the formula of summation. So solution, as we know, Z transform of A raised to K equal to Z upon Z minus A, where mod of Z is greater than mod of A and K is greater than or equal to 0. So by using this formula, if we consider Z transform of e raised to ak, e raised to a whole raised to k, it means that here if we compare, so I am getting a equal to e raised to a, and that is why I am getting it, that is equal to z upon z minus e raised to a, where mod of z is greater than mod of e raised to a and k is greater than or equal to 0. So directly I am getting the answer. So this is one of the way, and by using the definition also we can prove the same thing. How? So second method now. So method second, by definition of Z transform, Z transform of f of k equal to summation k varies from minus infinity to infinity f of k into z raised to minus k. So here f of k equal to e raised to ak and k is greater than or equal to 0, and therefore I am getting Z transform of f of k means e raised to ak, that is equal to summation, now k varies from 0 to infinity, f of k means e raised to ak and z raised to minus k. As we have to use r raised to k formula summation, so that is why you write this in the form of r raised to k. How? So summation k varies from 0 to infinity, so I can write it is a e raised to ak upon z raised to k. Now same thing I can write as summation k varies from 0 to infinity e raised to a upon z whole raised to k. Again by using the formula. So which formula? Since this one, r raised to k varies from 0 to infinity. It is 1 upon 1 minus r, where mod of r is less than 1. And that is why I am getting Z transform of e raised to ak equal to 1 upon 1 minus r. R is nothing but here e raised to a by z, where mod of r means e raised to a upon z is less than 1. So simplify this. So multiply numerator and denominator by z. So I am getting z upon z minus e raised to a, where e raised to a is less than mod of z. So we have to prove the same. So same thing I can write as, therefore Z transform of e raised to ak equal to z upon z minus e raised to a, where mod of z is greater than e raised to a, which is our requirements, hence proved.